Imagine you are on a spaceship. You are traveling far out into our solar system, past Mars, past the giant Jupiter, past Saturn with its beautiful rings. What's next? You would arrive at a very curious planet. This planet is named Uranus. It is a world full of mystery and surprises. Uranus is not like Earth or Mars or even Jupiter. It is special. It spins on its side. It has a strange, cool glow. It is a place that makes scientists scratch their heads and say, "Wow, this planet is a true wonder of our cosmic neighborhood, a distant, icy jewel that beckons us to learn more about its secrets." Uranus is the seventh planet from our sun. That means it is very, very far away. Because it is so far, it is also very, very cold. Think of the coldest winter day you have ever felt. Uranus is much, much colder than that. It is a giant ball of gas and ice. It does not have a solid surface like Earth where you could stand. If you tried to land on Uranus, you would just sink into its thick, swirling atmosphere. This atmosphere gives Uranus its unique blue-green color, a serene hue that hides the dynamic and extreme conditions beneath its cloudy veil. It's a color that hints at its chilly nature. What makes Uranus so fascinating? Well, for starters, it is a bit of an oddball. Most planets in our solar system spin like a top as they go around the sun, but Uranus is different. It is tilted so much that it looks like it is rolling on its side. Imagine a spinning top that has fallen over but keeps on spinning. That is Uranus for you. This unusual tilt means Uranus has some of the craziest seasons in the entire solar system. Some parts of the planet have daylight for many, many years, while other parts are in darkness for just as long. It's a truly topsy-turvy world out there. So, Uranus is a distant, cold, and tilted giant. It sounds pretty strange, right? That is exactly why it is so interesting to astronomers and space explorers. We want to understand why it is the way it is. How did it get knocked on its side? What are its clouds made of? Does it have hidden oceans deep inside? These are some of the questions that make Uranus a captivating subject of study. Join me as we take a journey to explore this far-out wonder, this blue-green enigma, and uncover some of the amazing facts about the planet Uranus. It's a cosmic adventure waiting to happen. When we look at Uranus through a telescope, what do we see? We see a beautiful, calm-looking ball. It has a soft blue-green color. This color is not paint. It comes from the gases in Uranus's atmosphere. The main gases are hydrogen and helium, just like in Jupiter and Saturn. But Uranus has something extra. It has a gas called methane. This methane gas is very good at absorbing red light from the sun. When the red light is absorbed, the blue and green light bounces back. That is why Uranus looks blue-green to us. It is like the planet is wearing a cool blue-green coat. Uranus is a giant planet. It is much bigger than Earth. In fact, you could fit about 63 Earths inside Uranus. That's a lot of space. Even though it is so big, it is not as heavy as Jupiter or Saturn. This is because it is made of lighter stuff. It is not a rocky planet like Earth or Mars. Instead, it is mostly a huge ball of gas and liquid. Deep inside, scientists think there might be a small, rocky core. But mostly, Uranus is a swirling world of hydrogen, helium, and those special ices that make it an ice giant, which we'll talk more about soon enough. The atmosphere of Uranus is a very dynamic place, even if it looks calm from far away. There are clouds there, but they are hard to see. These clouds are made of things like methane ice crystals. Scientists have seen giant storms on Uranus, some as big as continents on Earth. There are also very strong winds. These winds can blow at hundreds of miles per hour. Imagine winds so fast they could blow a car away. That is what it is like on Uranus. It is a world of extreme weather, hidden beneath that peaceful blue-green exterior, a constant reminder of the powerful forces at play. So, Uranus is a big blue-green ball of gas. It gets its color from methane. It is much larger than Earth, but not as dense as the other gas giants. It has a thick atmosphere with clouds, storms, and super-fast winds. It might look like a calm, distant marble, but it is a complex and fascinating world. Peeking at Uranus through our telescopes has shown us some of its secrets, but there is still so much more to learn about this beautiful and mysterious planet. Every new image, every piece of data, helps us paint a clearer picture of this remote giant. We often hear Uranus called an ice giant. What does that mean? Does it mean the planet is a giant block of ice like a colossal iceberg? Not exactly. The ice in ice giant refers to the materials found inside the planet. These are not just water ice like the ice in your freezer. Scientists use the word ices to describe materials like water, methane, and ammonia, when they are in a very cold, dense, and fluid state. These materials are much heavier than the hydrogen and helium that make up most of Jupiter and Saturn, the gas giants. That's a key difference. So, deep inside Uranus, below its gassy atmosphere, there is a thick, slushy layer. This layer is made of these ices, water, methane, and ammonia. It is not a solid layer of ice like on Earth's polar caps. Instead, it is more like a very hot, very dense ocean. How can it be hot and icy at the same time? It is because of the immense pressure deep inside the planet. This pressure is so strong that it keeps these materials in a strange, fluid state, even though the temperatures are incredibly high, thousands of degrees Celsius. It's a cosmic paradox. This icy mantle makes up a large part of Uranus. In fact, scientists believe that about 2/3 of Uranus's mass is this strange mixture of water, methane, and ammonia ices. This is different from Jupiter and Saturn. Those planets are mostly hydrogen and helium all the way through with smaller cores. Uranus and its neighbor Neptune have much more of these icy materials. That is why they get their own special category ice giants. They are a different kind of giant planet, a bridge between the gas giants and the smaller rocky worlds, a unique class of celestial bodies. Being an ice giant also helps explain why Uranus is so cold on the outside. While its interior is hot, Uranus doesn't radiate much internal heat out into space compared to Jupiter or Saturn. It's actually one of the coldest planets in our solar system, with atmospheric temperatures dipping down to around -224 degrees Celsius, -371 degrees Fahrenheit. That is incredibly frigid. This lack of internal heat emission is still a bit of a puzzle for scientists. So when you think of Uranus as an ice giant, picture a world with a vast, dense, slushy interior made of these special icy materials contributing to its unique character. One of the most famous things about Uranus is its extreme tilt. Imagine all the other planets in our solar system spinning like tops. They spin fairly upright as they orbit the sun. Now, picture Uranus. It is like a top that has been knocked completely over on its side. Its axis of rotation, the imaginary line it spins around, is tilted by a whopping 98 degrees. This means Uranus is essentially rolling along its orbital path around the sun. No other planet in our solar system has such a dramatic tilt. It is truly unique in this regard. Why is Uranus tilted so much? Scientists are not entirely sure, but they have a leading theory. They think that long, long ago, when the solar system was still young and chaotic, Uranus might have collided with a giant Earth-sized object. This colossal impact could have been powerful enough to knock the planet over on its side. Imagine a cosmic game of billiards, where a massive space rock struck Uranus with incredible force. This event would have reshaped Uranus's destiny, giving it its peculiar orientation that we observe today, a lasting scar from a violent past. This extreme tilt has a huge effect on Uranus's seasons. On Earth, our tilt of about 23.5 degrees gives us our familiar spring, summer, autumn, and winter. Because Uranus is tilted so much, its seasons are incredibly long and extreme. For a quarter of its long year, which is 84 Earth years, one pole of Uranus points directly at the sun. This pole gets continuous daylight for 21 Earth years. Meanwhile, the other pole is plunged into total darkness for 21 Earth years. Can you imagine a day or a night that lasts for 2 decades? That's the reality on Uranus. Then, as Uranus continues its journey around the sun, the situation flips. The pole that was in darkness now gets 21 years of continuous sunlight, and the other pole experiences 21 years of night. During the times in between, when the sun is shining over Uranus's equator, the planet experiences more rapid day-night cycles, similar to other planets, but still quite strange due to the sideways orientation. This bizarre seasonal pattern makes Uranus a fascinating laboratory for studying planetary atmospheres and how they respond to such extreme and prolonged changes in solar illumination. It's a world of perpetual light and shadow. Section 5. Faint and Fabulous, The Secret Rings of Uranus. You have probably heard about Saturn's magnificent rings. They are bright, wide, and easy to see with a good telescope. But did you know that Uranus also has rings? Yes, it does. Uranus's rings are not as famous as Saturn's because they are very different. They are much darker and much narrower. They are so faint that they were not even discovered until 1977. Scientists found them by accident when Uranus passed in front of a distant star, and the star's light blinked on and off as the rings blocked it. It was a surprising and exciting discovery. Uranus has at least 13 known rings. They are named using Greek letters or numbers, like the epsilon ring, which is the brightest and widest. Unlike Saturn's bright, icy rings, the rings of Uranus are made of very dark particles. Scientists think these particles might be made of water ice, mixed with some dark radiation-processed material. Or perhaps they are rocky. The particles in Uranus's rings range in size from tiny dust grains to boulders as big as a house. They are not shiny like freshly fallen snow, but more like chunks of charcoal. This darkness makes them hard to see from Earth. The rings of Uranus are also very narrow compared to Saturn's broad ring system. Some of Uranus's rings are only a few kilometers wide. Imagine a giant hula hoop around the planet, but very, very thin. How do these narrow rings stay in place? Scientists believe that small shepherd moons orbit on either side of some rings. The gravity of these tiny moons helps to keep the ring particles from spreading out. It is like cosmic sheepdogs herding their flock of ring particles. These shepherd moons play a crucial role in maintaining the structure of these delicate rings. Studying the rings of Uranus helps us understand how ring systems form and evolve around planets. They might be the remnants of a small moon that got too close to Uranus and was torn apart by its gravity. Or perhaps they are leftover material from when Uranus itself was formed. Even though they are faint and dark, these rings are a fascinating feature of Uranus. They add another layer of mystery to this already enigmatic ice giant, reminding us that even the darkest corners of our solar system hold beautiful and complex structures waiting to be fully understood. They are like delicate, dark ribbons adorning the tilted giant. Section 6. A celestial family, Uranus's many moons. Just like other giant planets in our solar system, Uranus is not alone on its journey through space. It has a whole family of moons orbiting around it. As of now, astronomers have discovered 27 known moons around Uranus. That is a lot of companions. These moons are not like our own moon. Many of them are quite small, and they are all very, very cold, icy worlds. They are named after characters from the plays of William Shakespeare and the poems of Alexander Pope. So you have moons like Titania, Oberon, Miranda, Ariel, and Umbriel. It's a literary theme for a celestial family. The 5 largest moons of Uranus are Miranda, Ariel, Umbriel, Titania, and Oberon. Titania is the biggest, but it is still less than half the size of Earth's moon. These larger moons are thought to be made of a mixture of ice and rock. They likely have icy surfaces, and some might even have oceans of liquid water hidden deep beneath their crusts, warmed by internal heat or tidal forces. Imagine watery environments so far from the sun. This possibility makes them exciting targets in the search for places where life might exist beyond Earth, even if it's a long shot in such frigid conditions. One of the most interesting moons is Miranda. It looks like it has been smashed apart and then pieced back together. Its surface is a jumble of different terrains. There are giant cliffs, deep canyons, and strange grooved features. One cliff on Miranda, called Verona Rupes, is thought to be the tallest cliff in the solar system, perhaps 5 to 10 kilometers or 3 to 6 miles high. Scientists think Miranda might have experienced a catastrophic impact in its past, or perhaps intense geological activity shaped its bizarre appearance. It's a real Frankenstein moon, a testament to a violent history. The smaller moons of Uranus are less well understood. Many of them are probably captured asteroids or comets, pulled in by Uranus's gravity long ago. They are dark, irregular shapes, and they orbit in complex patterns, some even sharing orbits or orbiting in a retrograde or backward direction. Studying these moons, both big and small, helps us piece together the history of Uranus and its system. Each moon is a little world with its own story, contributing to the rich tapestry of this distant planetary system, a diverse collection of icy bodies dancing around their tilted parent. Section 7. Found by accident: How we met Uranus. For thousands of years, people knew about 6 planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. These planets are bright enough to be seen in the night sky without a telescope. Everyone thought that was it. But then, in 1781, a musician and amateur astronomer named William Herschel was looking at the stars from his backyard in England. He was using a powerful telescope that he had built himself. He was carefully mapping the stars, night after night, a patient observer of the heavens above him, unaware he was on the brink of a monumental discovery. One night, Herschel noticed something strange. He saw an object that looked different from the stars around it. Stars usually appear as tiny points of light, even in a telescope. But this object looked like a small, fuzzy disk. He watched it for several nights. he saw that it was moving slowly against the background of stars. At first, he thought it might be a comet. Comets were known to move across the sky. He reported his discovery to other astronomers, sharing his curious observation with the scientific community of his time, sparking a wave of excitement and further investigation. Other astronomers started observing this new object. They calculated its orbit. They soon realized it was not a comet. It was too far away, and its orbit was nearly circular, like a planet. It was a new planet. This was a huge discovery. It was the first time in recorded history that a new planet had been found. It doubled the known size of our solar system overnight. It showed that there was more to our cosmic neighborhood than anyone had ever imagined. The universe, it seemed, still held many secrets, waiting patiently for curious minds to uncover them. William Herschel wanted to name the new planet Georgium Sidus, George's star, after King George III of England. However, that name was not popular outside of Britain. Other astronomers suggested names from classical mythology, like the other planets. The name Uranus, after the Greek god of the sky, was eventually chosen. Uranus was the father of Saturn in mythology, and Saturn was the father of Jupiter. It seemed like a fitting name for this new, distant world. And so, Uranus officially joined our solar system family, a testament to careful observation and the ever-expanding reach of human curiosity. Section 8: Uranus and its neighbors, a solar system lineup. Our solar system is a diverse place filled with different kinds of planets. We have the small, rocky inner planets Mercury, Venus, Earth, and Mars. Then we have the gas giants Jupiter and Saturn. And finally, we have the ice giants Uranus and Neptune. Uranus, being the seventh planet from the Sun, sits in a very cold and distant part of this cosmic family. It is about 1.8 billion miles, or 2.9 billion kilometers, away from the Sun. That is almost 20 times farther from the Sun than Earth is. Light from the Sun takes over 2.5 hours to reach Uranus. Compared to the gas giants Jupiter and Saturn, Uranus is smaller and has a different composition. Jupiter and Saturn are mostly made of hydrogen and helium, with a very thick atmosphere. Uranus, as an ice giant, has a higher proportion of heavier elements, those ices like water, ammonia, and methane, especially in its interior. This makes it denser than if it were purely gas, but still much less dense than rocky Earth. Its atmosphere is also much colder at the cloud tops than Jupiter or Saturn because it's farther from the Sun and generates less internal heat. When we look at Uranus next to its ice giant twin Neptune, we see some similarities and some differences. Both are blue-green, though Neptune is a more vivid, deeper blue. Both have similar sizes and masses, and both are classified as ice giants due to their composition. However, Uranus is unique because of its extreme axial tilt, which Neptune does not share. Neptune also has much more active weather patterns visible in its atmosphere, with giant dark spots and fast winds, while Uranus appears more serene, though it too has powerful winds and occasional large storms. These subtle differences make studying them together very informative. So, Uranus fits into a special category in our solar system. It is not quite like the gas giants, and it is certainly not like the rocky planets. It is a unique type of world, an ice giant sharing some characteristics with Neptune but also possessing its own distinct features, like its sideways spin and its surprisingly bland appearance at first glance. By comparing Uranus to its planetary neighbors, we learn more about how different planets formed in different regions of the solar system, and how they evolved over billions of years. Each planet is a piece of the puzzle, helping us understand the grand story of our solar system's formation and history. Section 9. The Enduring Mystery. Why we keep looking at Uranus. Uranus may be far away, cold, and a bit strange, but that is exactly why it is so important for us to study. It holds clues about how our solar system formed and how planets like it might exist around other stars. Every piece of information we gather about Uranus helps us understand the bigger picture of the cosmos. Scientists are always asking questions. Why is Uranus tilted so much? What is its internal structure really like? Why does it radiate so little heat? These questions drive us to explore, to send spacecraft, and to peer deeper with our telescopes. The unknown is a powerful magnet for the curious mind. The Voyager 2 spacecraft is the only probe to have visited Uranus up close. It flew by the planet in 1986. It gave us our first detailed images and measurements of Uranus, its rings, and its moons. Voyager 2's brief encounter revealed a world far more complex and dynamic than previously thought. It showed us faint rings, discovered new moons, and measured the planet's strange magnetic field, which is also tilted and offset from the planet's center. But a flyby is just a snapshot. There is so much more we need to learn, requiring new missions and sustained observation. Future missions to Uranus are being planned by space agencies around the world. Scientists dream of sending an orbiter and maybe even an atmospheric probe to study Uranus in much greater detail. An orbiter could stay there for many years, mapping the planet, studying its atmosphere, rings, and moons over a long period. An atmospheric probe could dive into its clouds, sampling the gases and measuring temperatures and pressures directly. These missions would revolutionize our understanding of ice giants, which we now know are very common types of planets in other solar systems around other stars. Uranus, the sideways ice giant, remains an intriguing and somewhat enigmatic world. It challenges our understanding of planetary formation and evolution. Its unique tilt, its cold atmosphere, its faint rings, and its diverse family of moons all present fascinating puzzles for scientists to solve. By studying Uranus, we are not just learning about one distant planet, we are learning about the processes that shape worlds across the universe. The allure of Uranus lies in its mysteries, and as long as there are questions to answer, humanity will keep looking towards this far-out blue-green jewel in our cosmic backyard, beckoning us to come explore.